All right, it's going to be tutorial 9, and we're going to be starting out doing emoji converters. Once again, thank you for joining, for those on the live and for those on the replay. Let's go.
In this tutorial, I'm going to show you something really cool that you can do with dictionaries. So here we have this program. We can type a message like good morning, followed by a smiley face. When we press enter, we get this beautiful smiley face. Or we can type I am sad with a sad smiley face, and it gets translated to this beautiful emoji. So this is another application of using dictionaries. We have a dictionary that maps these characters into smiley faces. So let's go ahead and build this program together. We start by calling the input function. Here we pass a greater than symbol as an indicator for the user to type a message. We get that message, store it here. As you know, that is a string. Now we need to split the string by a space. So if the user types good morning with a smiley face, we want to break this down into 3 words: good, morning, and smiley face. To do that, we can call the split method. So we call message.split and pass a string with 1 space as the separator. What this method does is basically it goes through the string, and anywhere it finds this character, in this case a space, it uses that as a boundary to separate this string into multiple words. And then it will return a list. Let me show you. So let's store that here, words, and then print it on the terminal. Let's go ahead and run our program. So if we type good morning, sunshine, enter, we get a list with 3 items. Each item is a string. Okay. Now, back to our program, we need to define a dictionary for mapping special characters like these two into a smiley face. So we can call that emojis, set it to curly braces. Here we add a key value pair, a smiley face, and we map that to a string. In the string, we want to add an emoji. If you're on a Mac keyboard, you can press Control, Command, and Space, and this should bring up this emoji box. If you're on Windows, honestly, I really don't know how you can do this, but there must be applications that do this for you. So let's go ahead and pick this happy smiley face. Good. Now let's add another key value pair for a sad face. We map this to this face here. Good. So we have a list of words. Now we need to loop through this list, get each word, and potentially map it to an emoji. So we can write a for loop for word in words. Now we want to go to our dictionary and see if you have an item with this word as the key. If you have an item with that key, then we'll get its value. Otherwise, we want to use the same word. So if the user types good morning, we don't want to translate those words. We just want to return those. So that is the case where we use the get method to supply a default value. So we want to get an item with the key word. And if we don't have an item with that key, we simply use that word as the default value. Now, similar to the exercise that we did in the last tutorial, we need an output variable. So let's define that here, output, set it to an empty string. Now back to line 9, we get the return value of the get method and add it to our output variable. So output plus equals whatever we get from the get method. And finally, we need to append a space at the end. That's it, we're done. So let's print the output and run our program. I'm going to type good morning, sunshine, with a smiley face. We get that. Beautiful. Let's try a sad face as well. I am sad. Too bad. Beautiful. So as you can see, dictionaries have a lot of use cases in real applications. Here's a solution from the last tutorial where we created an emoji converter. Now, so far we've been writing all our code right here in app.py, but as our programs grow, we need a better way to organize our code. We need to break up our code into smaller, more manageable, and more maintainable chunks, which we call functions. So a function is a container for a few lines of code that perform a specific task. For example, you have learned about a few of the built-in functions in Python like print and input. Each of these functions have a purpose. They know how to perform a specific task. So when building large, complex programs, we should break up our code into smaller, reusable chunks, which we call functions, to better organize our code. And that's what I'm going to show you in this tutorial. So let's write a simple program for printing a greeting message. So we're going to do a print, hi there, and let's add another message, welcome aboard. So here we have a simple program with only 2 lines of code. Now let's say these 2 lines, potentially we're going to need them in other programs. So we can put them in a function that we can reuse. Let me show you how to do that. So we start typing out def, that is a reserved keyword in Python, and it's short for define. When Python interpreter sees this, it knows that we're defining a function. Next, we need to give our function a name. Let's say greet underline user. So all the best practices you learn about naming your variables also apply here, which means you should name your functions with lowercase characters. If there are multiple words, you need to separate them using an underscore. And you should always, 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 always use meaningful and descriptive names for your functions. So here we're defining a function called greetUser. After that, we need to add parentheses followed by a colon. Now, you know that whenever we add a colon at the end of a line, we're telling Python that we're defining a block of code. So when we press enter, the next line is indented. Now, any code that we write here will belong to this function. So I'm going to move these 2 lines, these 2 print statements inside of our function. We can simply press tab to indent them. Beautiful. Also, let's remove this extra line break. That is better. So these 2 lines now are part of our greet user function. So whenever we call this function, these 2 lines will be executed. Okay. Now let's remove indentation. So here we are outside of our function. Let's do a print statement and print start. After that, let's call our function. So greet user. And finally, let's do another print statement and print finish. Now we have this little warning here, this underline. If you hover your mouse over this line, this tooltip is telling you that we should add 2 blank lines after function definition. This is coming from PEP 8, which is a document that defines the best practices for formatting our code. We'll look at that in the future. So for now, to make PyCharm happy, let's add an extra line break after this function. So whenever we define a function, we need to add 2 line breaks after. Okay. So now let's run our program and see what happens. All right, so we get 4 messages on the terminal. First, we get the start message. Then we get the messages coming from our greet function. So hi there and welcome aboard. And finally, we see the finish message. So let me explain the flow of our program. When Python runs this code, it doesn't actually print these 2 messages on the terminal because these lines of code are inside of this function. So they will only get executed if we call this function. If we don't call this function, these lines will not get executed. Okay? So the execution of our program actually starts here. The first message that we see on the terminal is the start message. After that, Python sees that we're calling the greet function. So it will jump over here and then execute these 2 lines. Then it will jump outside of this function and continue the normal execution of our program. So it will print the finish message on the terminal. So this is how functions work. Also note that the order of this code matters. So here we're calling the greet function after we have defined it. If you try to call it before you define it, you will see an error. For example, if we call the greet user function right here, see, we immediately get this red underline, which says unresolved reference greet user, which basically means Python doesn't know what is this greet user. It's not defined anywhere. So we always define our functions first and then call them. Here's the function we created in the last tutorial. Now I got a question for you. What is the difference between calling this function and the print function of Python? The difference is that the print function takes some information, in this case, the message that we want to print, but our greet function doesn't take any information. Wouldn't that be nicer if you could pass the name of the user here, and then instead of saying hi there, we could print the name of the user? So in this tutorial, I'm going to show you how to pass information to your functions. And that is pretty easy. So back to the definition of our greet user function. Inside of this parenthesis, we can add parameters. These parameters are placeholders for receiving information. For example, we can add a name parameter, and with this, we can pass the name of the user when calling this function. So let's pass John here. Now, when we call this function and pass this value, this name parameter will be set to John. So it will act like a local variable that we define inside of this function. Just imagine we didn't have this parameter, and instead we had a variable like name that was set to John. Now here, we could simply print the name of this user. So we could use a formatted string and print the value of the name variable, right? Now, we don't really have this local variable defined in this function. We have a parameter. It's exactly the same thing. So with these parameters, we can receive information in our functions. Now let's go ahead and run this program. So take a look. We get, hi, John, welcome aboard. We can take this to the next level. Now we can call this function one more time. So greet user, and this time supply a different name. Let's say Mary. So we are reusing our greet function and passing it a different value. Imagine if we didn't have this function, we would have to repeat this line twice, once for hi John and another time for hi Mary. So this is the benefit of defining functions. We can take a few lines of code that have a specific purpose and put them inside of a function. So now let's run our program one more time. There you go. So we get hi John, welcome aboard. Then we get hi Mary, welcome aboard. Now note that when a function has a parameter, we are obligated to pass a value for that parameter. So if we remove John from here and run our program, we get this type error, greet user missing one required positional argument. Argument in programming is the value that we supply to a function. So back to this example, Mary in this case is an argument that we pass to the name parameter. A lot of programmers don't know the difference between parameters and arguments and think they are the same, but they are not. Parameters are the holes or placeholders that we define in our function for receiving information. Arguments are the actual pieces of information that we supply to these functions. Okay, so let's bring back this John string. Okay, now we can also define multiple parameters. For example, let's rename this parameter to first name. As I told you before, you can right click here, go to refactor, and then rename, or preferably you can use a shortcut. So the shortcut for this on Mac is Shift and F6. And this brings up the rename dialog box. Here we can change this to first underline name. Now we can add a second parameter, so comma, followed by last underline name. So back to our formatted string, let's also print the last name. Beautiful. So here when calling these functions, then we can supply another argument. So John Smith, and let's delete this line. We don't really need it anymore. Run our program. Take a look. Hi, John Smith. So in the last tutorial, you learned that whenever we define parameters for our functions, we should always supply values. Otherwise, we'll get an error. Let's look at that error one more time. So I'm going to delete the second argument and only pass John. Run our program. We get this message. Greet user missing one required positional argument. So these arguments that we have here, like John and Smith, we refer to these as positional arguments, which means their position or order matters. In other words, the first argument we add here is the value for the first parameter, and the second argument is the value for the second parameter. So if we change their position or order, we'll get different result. Let's take a look. Let's pass Smith first and then John. Okay. Delete. That's good. Let's go with this. So instead of getting hi John Smith, we get hi Smith John. So that is the reason we refer to these arguments as positional arguments. Their position or order matters. But in Python, we also have keyword arguments, and with those, the position doesn't matter. Let me show you how they work. So let's say here we want to pass John as the value for the first name parameter. We can simply specify that here. So first name equals John. Now what we have here is a keyword argument. So this combination of having the parameter name followed by its value is what we call a keyword argument. And with these keyword arguments, the position doesn't really matter. So here we're supplying John as an argument for the first parameter. Now, similarly, we can use a keyword argument for Smith. Let me show you. So last name equals Smith. So now we have two keyword arguments. So with these keyword arguments, we don't have to worry about the order of the parameters. That doesn't mean we should always use keyword arguments. Not really. Most of the time, we use positional arguments. But in certain situations, these keyword arguments help us improve the readability of our code. So on line 7, it's quite clear that we're supplying Smith as the last name and John as the first name. Now, in this particular example, even if we didn't have the keyword arguments, just passing two positional arguments like John and Smith would be sufficient because it's easy to guess what is the purpose of these arguments. But sometimes you're dealing with functions and you're passing numerical values to them. In those situations, it may not be quite clear what these values represent. Let me show you an example. Let's say we have a function for calculating the total cost of an order. So we can call that calculate underlying cost. So when calling this function, we need to supply three pieces of information. One is the total cost of all the order items, let's say $50. The other is the shipping cost, let's say $5. And the last piece is a discount, let's say 0.1. Someone reading this code may not be sure what these three values represent. In this case, we can improve the readability of this code by using keyword arguments. So we can prefix each value with the name of the parameter they target. For example, we can set total to 50, and then shipping to 5, and discount to 0.1. Now, if we give this code to someone else, they can immediately tell what these values represent. So that is the power of keyword arguments. So here's what I want you to take away. For the most part, use positional arguments. But if you're dealing with functions that take numerical values, see if you can improve the readability of your code by using keyword arguments. You simply prefix the arguments that you pass with the name of their parameters, and this will increase the readability of your code. Now, there is one more thing you need to know about keyword arguments. These keyword arguments should always come after positional arguments. Let me show you what I mean. So back to our simple greet user function. Let's use a keyword argument for the first name. So let's set first name to John and see what happens. Look, we immediately get this error. Take a look. Positional argument after keyword argument. So when calling this function, we're supplying one keyword argument and one positional argument. And Python doesn't like this. So if you're mixing positional and keyword arguments, you should always use the positional arguments first and then the keyword arguments. In other words, let's remove this keyword argument here. So John is now a positional argument, is targeting the first parameter, right? Now, after this positional argument, we can supply any number of keyword arguments. So if we set last name to Smith, look, Python doesn't have any problem with this because we're adding a keyword argument after a positional argument. So let's quickly recap. For the most part, use positional arguments. If you're dealing with functions that take multiple numerical values and it's not quite clear what those values represent, use keyword arguments to improve the readability of your code. And finally, if you're passing both positional and keyword arguments, use the keyword arguments after the positional arguments. So far, you have learned how to create functions and send them information using their parameters. In this tutorial, I'm going to show you how to create functions that return values. This is particularly useful if you're doing some kind of calculation in your function and you want to return the result to whoever is using your function. Let me show you. So let's start by defining a function called square. This function simply calculates the square of a number. So we need to add one parameter here, that is our number. Now here we want to calculate number times number. That is the square of a number. Now, to return this number outside of this function, we simply use the return statement. So return. Now, our square function is very simple. It only has one line of code. But in a real program, you might have a function that has 10 lines of code to calculate something. So this return statement is very valuable. With that, we can return values to the callers of our function. So with this, when we call the square function, let's say we give it 3, now this function returns a value, just like the input function of Python. This input function waits for the user to type something and press enter, and then it will return the user's input as a string. So we can get it and store it in a variable like this, right? We have the same story with our square function. So our square function returns a value. We can simply get it and store it in a variable. Let's call that result. Now we can print result on the terminal. There you go. So result is 9. We could also pass this function call directly inside of the print function without defining a separate variable. Sometimes this is useful for writing shorter code. So in this case, we don't really need this result variable. We simply want to print the square of 3. So we could simply pass this function call right here as an argument for the print function. So let's delete this variable. Now our code is shorter. So with this, we're calling the square function. This returns a value, and we'll pass that value as an argument to the print function. Okay? When we run this program, we get the exact same result. There you go. Now, what happens if we don't use a return statement in our function? So in the last example, we simply used a print statement. Let's temporarily remove this return statement and print the result on the terminal like this. So let's run our program one more time and see what we get. We get 2 things on the terminal, the number 9 and none. What is happening here? Well, when Python interpreter executes this code, first it will call the square function. So the control moves to the square function. Here we calculate the square of this given number and then print it on the terminal. That is the reason we see 9 right here. Now, by default, all functions return the value none. So if we don't have a return statement here, by default, Python returns none. None is an object that represents the absence of a value. It's like nothing, or null in C, C++, Java, and JavaScript. So in this example, we didn't have a return statement, and by default, Python returned none from this function. So after this square function is executed, the value none is returned and passed as an argument to the print function. That is the reason we see none on the second line. So here are the 2 things you need to take away from this tutorial. By default, all functions in Python return none. You can change that. So if you have a function that calculates something, you can return the result using the return statement. Here's the code for our emoji converter program that we wrote earlier. If you missed that tutorial, make sure to go back and watch it. As I told you before, there is a table of content right below this video in the description. So you can simply click on the emoji converter tutorial to watch it. Now, your exercise is to reorganize this code using a function. So I want you to extract a function in this code. Because this algorithm for converting these smiley faces into emojis is something that we probably want to use in a lot of different applications. We can use it in a chat application, in an email application, and so on. We don't want to write all this code every time. We want to convert these characters into smiley faces. So out of all these lines of code that we have, from line 1 to line 10, the lines 2 to 9 belong to our algorithm. All these lines together implement this feature. So you should put these lines in a separate function. Now, why don't we have the input in that function? Because the input can come in different forms. Currently, we're using the input function to receive the input from the terminal, but in other applications, we might receive the input from a graphical user interface. So the input can come in different forms. We don't want to put that in our function because this line will not be reusable. We want to give our function the actual message as a string. We don't care how we got that message. In one program, we might get it from the terminal. In another program, we might get it from a graphical user interface. So that is the reason this line of code should not be in that function. By the same token, you shouldn't include the last line in that function because what we do with the output is different from one program to another. In this program, we're printing the output. In another program, we might send that output as an email or as a response in a chat application. So as a general rule of thumb, your functions should not worry about receiving input, and printing it. These lines of code should not belong to your functions. So go ahead and reorganize this code by extracting a function. All right, on the top, first we need to define our function. So we type def, give our function a name like emoji underline converter. So the name of this function clearly tells me what it does.
All right, so we're going to go to pause there. Top line, we're going to put def emoji converter.
Each function should be responsible for one and only one task, and that task should be clearly explained in the name of the function. Okay, so our emoji converter function should take a parameter. We call that message. That is a string, right? Colon. Now we need to move the lines 5 all the way to the end of our for block into that function. So let's select all these lines. We can cut them from here by pressing Command and X on Mac or Control and X on Windows. Then we paste them here. As you can see, these lines are automatically indented, so they are part of the emoji converter function. If this didn't happen on your computer, make sure to select these lines and use the tab to indent them. All right, so here's our emoji converter function. Beautiful. Now, after that, in the main flow of our program, first we get the input from the user. We store it in this variable message, and then we call emoji converter and pass this message. This function should return a value. That is what we calculate at the end of this function. So right after this for block, we need to add a return statement, return output. Now that our function returns a value, we can get it and store it in a separate variable. Let's call that result. And then we can simply print that here, or we can make this code shorter. We don't really need this variable here. So we can simply call the emoji converter and print the result like this. Now here we have an underline because, as I told you before, we need 2 blank lines after our function definitions. So currently we have only 1 blank line. We need to add another blank line. Good. Let's go ahead and run this program to make sure everything works as before. So I'm going to type a message like good morning with a smiley face. Good. Let's run it one more time. I'm sad. Too bad. Okay, beautiful. So here's the final result. We defined this function called emoji converter. This function takes a parameter called message and finally returns the output. In this tutorial, I'm going to teach you guys how to handle errors in your Python programs. So let's start by writing a small program to get the user's age from the terminal. So we call the input function input, add a label here like age. This returns a string, so we need to pass it to the int function and then store the result in a variable called age. Now let's print age to make sure we have implemented everything properly. Run our program. We type 20. 20 is printed here. Beautiful. Now look at the exit code of this program. Exit code 0 means our program terminated successfully. There were no errors. But what if we run this program one more time, and instead of entering a numerical value, we enter something like ASD. We get a value error with this message, invalid literal for int with base 10. Basically, what this message is telling us is that this string ASD does not contain a valid whole number that can be converted to an integer. Now look at the exit code of this program. Exit code 1 means our program crashed. So 0 always means success, and anything but 0 means crash. Now, as a good Python programmer, you should anticipate these situations. You don't want to let your entire program crash just because the user entered an invalid value. So instead of letting the program crash, you should handle this situation and print a proper error message. And that's what I'm going to show you in this tutorial. Now, before going any further, look at the type of the error we get here, value error. So remember this. We're going to get back to this shortly. Now, how can we handle these errors? In Python, we have a construct called try except. We use that to handle errors. Let me show you how it works. So on the top, we type try colon. Now, as you know, we're defining a code block. So I'm going to move these two lines inside of our try block. So press tab here and remove this blank line. Now, these two lines are part of our try block, right? So after try, we type except, and then we add the type of the error that our program may encounter. That is value error, okay? Then we add a colon, and in this block, we can define what should happen if our program encounters an error of type value error. In this case, we want to print a proper error message. So print invalid value. So with this try and except, we're telling Python, hey, go ahead and try running these two lines of code. If you encounter an error of type value error, then instead of crashing the program, print this error message on the terminal. So this is how this works. Now, more accurately in programming terms, we refer to this kind of error as an exception. So an exception is a kind of error that crashes our program. So if the user enters an invalid value, this line of code, line 2, will raise an exception, and on line 4, we'll catch it and print this error message so our program will no longer crash. Let me show you. So let's go ahead and run this. Age 20, everything works just like before, and the exit code is 0. Beautiful. Let's rerun this program and enter ASD. So we get this proper error message, invalid value, and once again, the exit code is 0. So that means our program completed successfully, it didn't crash. Now, we can also handle different kinds of errors or exceptions. For example, right after we get the age, let's define a variable, income, and set it to 20,000. And then define another variable called risk and set it to income divided by age. Let's run this program and enter 0 as the age to see what happens. So 0 is obviously a numerical value. So when we enter this value, technically we shouldn't get any exceptions. Take a look. Our program crashed with a 0 division error because we cannot divide a number by 0. Once again, look at the exit code. So we couldn't catch this kind of error or this kind of exception with this except block. This except block is only catching exceptions of type value error. And this happens when we try to convert a non-numerical value to an integer. So in a situation like this, we should handle different kinds of exceptions. We can add another except statement for an exception of type 0 division error. Now, in this block, we can print a different kind of message, like age cannot be 0. Let's run our program one more time. Now, I'm going to enter 0 as the age. So we get this error message, age cannot be 0. And look at the exit code. It's 0, so our program didn't crash. So to recap, we use try except blocks to handle exceptions that are raised in our programs. As a good programmer, you should always anticipate these kind of exceptions and handle them properly.
All right, we're going to go ahead and stop there. If I have time, I'll go ahead and actually do a standalone video for the emojis because I'm actually on a PC and I believe the person who Mosh is on a Mac. So if I have time, I will do a standalone video and probably put it in the playlist. Eventually, I'll going to make a whole playlist of this tutorial and see how it goes. Once again, if you're having issues and you need to go back, watch this video. In particular, the emoji converters, that was kind of a lot of information to process. So go back, take your time with that one and keep learning. All right, that was tutorial 9, and tomorrow will be Friday, tutorial 10. So everyone take care. And on that note, I'll see you tomorrow.